Okay, this is lesson 2.3, Solving Inequalities Using Multiplication and Division. The core concept today is that you can use multiplication and division properties of inequality. If you multiply or divide each side of an inequality by the same positive number, it produces an equivalent inequality and no further steps are needed. Let's take a look. Solve the inequality and graph the solution. So we look at what's being done to the variable. On the left, n is being divided by 7. We will multiply both sides by 7. Note that since 7 is positive, this does not change or reverse the symbol, but negative 1 times 7 is a negative 7. And then to graph it, have a solid closed circle, and it would point to the right. For step 2, this time the variable's on the right. It's being multiplied by 1/5, so I can undo multiplication of 1/5 by multiplying by the reciprocal, and again I'm multiplying by a positive quantity on both sides. So a negative 6.4 times 5 is negative 32. Keep the inequality as written, or you could reverse the whole thing to get the variable on the left, but w is definitely less than negative 32. Less than or equal to, I should say, and it points to the left. For 3, we are undoing multiplication, so I am dividing both sides by 4. Notice that it is a positive 4. So b will be greater than or equal to 9. And it's a closed circle, and it'll point right. When multiplying or dividing each side of an inequality by the same negative number, so this is the key word right here, negative number, it's going to change the direction of the symbol. We would reverse the symbol to produce an equivalent inequality. So you can see the numbers negative 6 is less than 8. If you multiply both sides of that inequality by a negative 2, 12 is greater than negative 16 because we've reversed the direction, or right here. Notice the difference right here between these two. Okay? So the reversal has to take place in order to maintain a true inequality. So looking at this number line, just as a visual, when you multiply 3 and 5 by negative 1. So if we start over here on the right, you can see 3 is less than 5. When we get over here to the left, we have negative 5 is to the left of negative 3, which makes negative 5 less than negative 3. So if we wrote the 3 on the left again, so negative 3, see the symbol that it sees? It is greater than negative 5. So you can see the difference between the symbols, keeping the same numbers on the same side. You would have to reverse the symbol. Okay? So let's try some. In this example, example 2, number 6, we are going to multiply both sides by a negative 5. And again, we have nothing that will let us know that we have to reverse it other than just remembering that rule. So x would be greater than or equal to 25, and you can graph. And point to the right. For 7, over here on the right, we will multiply both sides by a negative 10 over 1. So a negative 10, reverse the symbol, will be less than or equal to z, and then I can rewrite it to be z is greater than or equal to negative 10, so that when I graph it, I can see that the arrow will point to the right. Okay, for number 9 on this example, we're going to divide both sides by -2. So R, reverse the symbol. And number 10, we'll divide both sides by a -0.4. And I just noticed that every single one of these examples had a closed circle. So make sure that if the symbol is a less than or a greater than with an open circle, that you're graphing it correctly. So y, and we reverse the symbol because we are dividing by a negative, will be less than or equal to 30. So closed circle, and it points to the left. In example 3, you have at most $3.65 to make copies. Each copy costs 25 cents. Write and solve an inequality that represents the number of copies you can make. Well, I know that if I'm going to pay 25 cents per copy and let x be equal to the number of copies, I could take my 0.25x, and at most is $3.65. So it could be less than that. So I could do less than or equal to the 3.65. And in this case, I'm dividing by a positive value. And make sure that you realize that unless we're dealing with temperatures, we're probably not going to get a negative coefficient in a word problem. So you have to think of the context of the problem. So when I divide $3.65, I get x is less than or equal to 14.6 copies. But let's think about this, right? The number of copies I can make is 14 copies. Because if I did 15, I would be greater than. In example 4, the maximum speed limit for a school bus is 55 miles per hour. Write and solve an inequality that represents the number of hours it takes to travel 165 miles in a school bus. So we have our distance, rate, time, and in this problem we know the distance and we know the rate, and we're missing the time, and we want to know the number of hours. So since that's the maximum speed, our distance, we could travel 165 miles and less than or equal to 55 times the time. So we could divide both sides by 55, and we could get that 3 less than or equal to t, or we write t greater than or equal to 3 hours.